So here I have three scatter plots showed pulled up, and if you look at the three of these, if you compare them, this one on the left has the most clear linear trend. The points are the closest together and the closest to being in a straight line pattern. If you notice, this one also has the R value that's the closest to 1 out of any of the three. Now this is a positive R value because you can see the points are going up generally as they go from left to right. If they were going down from left to right, then it would be a negative R value. The scatter plot in the middle, that one, really you can't see any kind of trend. There doesn't seem to be any pattern whatsoever. Notice for this one, the R value is negative, but you really wouldn't be able to tell if this were negative or positive. The most important point here is that the R value is really close to 0, which means there's no linear relationship at all. And last of all, this one on the right, this one looks like it has a positive trend. So the points seem to be going up from left to right. Not in a very obvious straight line pattern, but they do seem to be trending up from left to right. So notice this one has an R value of 0.719. So it's not nearly as close to 1 as the one on the left of the screen is. That one was 0.908, and there was a much clearer linear pattern. This one is 0.719, and there's a pattern, but it's not super clear. Okay, so that was the first thing I wanted to talk about. And next I want to talk about what happens if you're taking the test and it won't give you the option of opening a data set in StatCrunch. I tried to get all of the problems set up so that it would, but sometimes my math lab doesn't do exactly what I want it to. So I just want to make sure that you have another option if that doesn't work for some reason. So I'm just going to show you an example. This is just a problem that was in your homework. So if you're looking at a problem like this, what you should be able to do is, if they give you a data set like this in a table, you should be able to click on the little boxes at the upper right side of the table, and it should give you an option to open in StatCrunch. So if we went ahead and clicked on that, then it's going to put your numbers, even the column headings, in StatCrunch for you. Now, if it doesn't give you that option, so if it comes up here and it only says copy to clipboard or open in Excel, there's still another way that you can use StatCrunch for this. It just means that you'll have to type in the numbers yourself. So if it doesn't give you that option, then what you need to do is just open another browser window, and what you need to do is just go directly to the StatCrunch website. And to do this, you can just type in statcrunch.com. And it'll take you there, and it should, if you're already signed into My Math Lab, it should not make you sign in. If it does make you sign in, just use the same login ID and password that you use for My Math Lab. So once you get this pulled up, then what you would do is, if you want to put in some data, just click on Open StatCrunch. And then you're just going to enter the data that they gave you. So in this problem, we had the systolic blood pressure and the diastolic. So I'm going to go ahead and type those in for my column headers just so I know which one's which. And then I'm just going to type the numbers in there. Oops. And then once I get done typing all the numbers in, I can go ahead and do whatever I need to do for the problem. So that's always another option that you can use. So here's a linear regression problem. And what we're looking at here is the mortgage rate, the mortgage interest rate, versus the number of months homes were listed for sale. And we want to see if there's a relationship between those two. So I already went to StatCrunch and typed in the data that's in this table. And for this one, since we're only talking about the interest rate in the months, I didn't type in the years. I didn't need to do that. So in this first part, where it asks you to find the linear correlation coefficient, then what we're going to do in StatCrunch is do the linear regression procedure, and that will give us the correlation coefficient. So I'm going down to regression, simple linear, and then for my X, I'm going to put in interest rate, and for my Y, I'm going to put in months. And if you're in my math lab and it's letting you open things in StatCrunch, it'll already have the column headings there for you. Okay, and then all I have to do is go down to the bottom and click on Compute, and that automatically gives me a whole bunch of information. It's going to give me the linear regression equation right here. It also gives me the correlation coefficient, the R value, right here. And then down here in this line, or in this row that says slope, it's going to give me the test statistic and the p-value. Just remember that you're looking for the row that says slope. Okay, so from this, I could answer this question. So I've got the linear correlation coefficient, so my R is negative 0.569 if I'm rounding it to 3 decimal places. Okay, and then my linear regression equation in StatCrunch, the variable on the left is always the Y, and the variable on the right is the X. And they use the column headers instead of Y and X. So this would be Y equals 16.450 minus 1.656 times X. So there's my equation of my linear regression line. Okay, then the other thing that this will do automatically for you is it will give you a scatter plot. So if I go back to StatCrunch and I click this arrow on the bottom right, it will take me to the scatter plot. Now this one, because there weren't very many data points, it's kind of hard to tell what's going on here. But here where it's asking me how well the linear regression line fits the data points, not especially well. There are a couple that are way off the line, like this one. So that one we could probably consider an outlier. But this is a way to get the scatter plot, if that's what you're looking for. Now the other thing that we can do, going on to this third part C down here, is if we're trying to do a hypothesis test. So if we're trying to confirm that there really is a linear relationship between the variables, then what we would look at is the test statistic and the p-value. So then we're going back to this row of our table over here that has slope. So our test statistic is under where it says t-stat. So our test statistic is negative 1.955 if we round it to 3 decimal places. Our p-value is 0.0864. Okay, now for the conclusion of this, and this is where it's a little bit easy to get mixed up, I know. This told us to use a 5% significance level, so significance level of 0.05. So what we're testing is whether the p-value is smaller than the significance level, so if it's smaller than alpha. If it is, then we have a positive conclusion. If it isn't, we have a negative conclusion. So for this one, if we compare our p-value, which is 0.0864, and our significance level, the p-value is actually bigger. So the answer to this is no, or it's false. So what that would mean is that for our conclusions, they're negative. So we would not reject the null hypothesis. And we would say there's not sufficient evidence to support the claim. So there's not sufficient evidence that they're of a linear correlation, because that was our claim up here. Okay, so now in part D, what it's asking is to estimate the number of months a home would have been listed for sale if the interest rate were 5.5%. So the answer to this and how you get there depends on what you came up with for your test result up here. What we came up with up here was that there's not sufficient evidence that there is a linear correlation. So that means we can't use our regression equation to make this estimate. So the only way that we can estimate this number of months is by using the average of the numbers of months up here in the table. So to do that, what we would need to do is go back to our StatCrunch and just find the average of the numbers of months here. So to get that really quick, we can do stat and summary stats in columns. And we just want the average for the month. If we just leave everything like it is here and just do compute, it's going to give us a whole bunch of other information. But it gives us what we want, which is 6.55 for the mean. So the only estimate we can make for the mean is just listing the average of the number of months. So that would be our estimate. Okay, then if we go on, we've got another question here, and that is to take the data that we already had and delete the values for the year 2002, and then go ahead and repeat all these questions. So our values from the year 2002 were the very first row of the table. So I'm just going to go back and just delete these. And then I'm going to redo my linear regression. I'm just going to go ahead down here and click compute. And then it gives me everything I want just by doing that one procedure. So what we have here, here's our regression equation. Our correlation coefficient this time is quite a bit higher. Before it was negative 0.569, and this one it's negative 0.807. So it's closer to -1, which means it's a better relationship. We can look at our test statistic down here. Is negative 3.62, and our p-value is 0.0085. So our p-value is much smaller than it was in the first question. If we look at our scatter plot, and again, with so few data points, it's kind of hard to tell how well this fits the the data, but we do have most of the points a little bit closer to the regression line. Okay, so if we were just looking at the part C and D for this one, for part C, we could list our test statistic, which would be negative 3.62, our p-value, which would be 0.0085. So what that would mean is that our test conclusions are going to be positive. Again, we're comparing our p-value of 0.0085 to our significance level, which was 0.05. This time the p-value is smaller than the alpha. So we have a true statement, which means our conclusions are positive. That means that we do reject the null hypothesis, and we'd say there is sufficient evidence of a linear correlation. Okay, so those are kind of the two things that you can run into. And just remember, in something like this where we had a negative R value, that means that our basic trend is that our data is going down from left to right. You can see with the regression line here, it's going down from left to right instead of going up.